So I think, so here we are we're reviewing the algebra topics. And I talked last time about the domain of a function. And so I want to continue and do another couple examples there. So the first one, if you have a function, this, by the way, is a radical function because the variable is under the radicand, or is under the radical. And so that means that x plus 2, which is the radicand, must be greater than or equal to 0. So we're going to have to solve that inequality. We require that x plus 2 is greater than or equal to 0. Oh, I need to put the, sorry, I thought I was on .cam view. Let me start over. I'm going to switch screens here. Probably you zooming in could see that, but the class here couldn't because I had the wrong setting. So let me just start over, and so that we are all on the same page. We're all in this together. And there we go. That's better. Okay, take 2. The domain of a function. We have an example here. Our function f of x is the square root of x plus 2. And we require that x plus 2 be greater than or equal to 0 because you cannot take the square root of a negative number. So, solving this inequality, I'm going to subtract 2 from both sides. And that gives me that x is greater than or equal to negative 2. So the domain then is the set of all x such that x is greater than or equal to negative 2. And if I put this in interval notation, if you think about it on the number line, here's negative 2. This equal sign says that I can include negative 2, and in interval notation we use a square bracket like that. And then it is everything above greater than or equal to negative 2. So we go in the positive direction because it's greater than or equal to. And this sets up our interval notation. If you see that graphically, you can also then write it as negative 2, infinity like that. And just a reminder, the square bracket means that we include the value of negative 2. Okay, so that's an example of the domain, finding the domain for a radical function. I also want to do an example of finding the domain from a graph. Okay, so let's take a look at that. Any questions on this one? Okay, so I'm going to graph a function here. It's a line segment that I'm drawing here. And I'm interested in knowing what is the domain of that function. You can see it's a function because it passes the vertical line test. So every vertical line, if I were to draw it across this entire function, only intersects the graph one time. And that's the requirement that we need in order for a graph to be a function. So it is a function. I want to find the domain. And the domain just simply refers to all input values. So those are the x values. The x values are the input for your function, and the y values are the output. So what are the possible input values? So we can't put in -4 or anything over here because there's nothing there, okay? The graph starts at -3 and it goes up until we reach 2, but it does not include 2 because look at this open circle here. That means you're not including that point there. So 2 is out of the domain because of that open circle, whereas -3 is included in the domain because of the closed circle, okay? So the domain for this function would be the set of all x such that it ranges from -3 to 2. So -3 is less than or equal to x, which is strictly less than 2. And if I put that in interval notation, it would be -3, 2, like that. Okay? If you want to talk about the range now, you're talking about y values. So I'm going to go ahead and write it with the y values in there. And this time, the range is the output, the possible output. So we're talking about the y direction, the vertical direction. So we're going to start down here at the bottom at -2. The function doesn't exist at -2. If you're talking, I mean, the range, the -2 is not in the range because of this open circle here. But everything between -2 and 3, that's a 3, everything between there is in the range. Notice that my motion is vertical now, okay? The function doesn't exist above 3 because this is blank up here, and it doesn't exist below -2. It's blank there. It's also blank right in that circle. So it would be from -2, the set of all y, such that -2 is less than y, strictly less than, which is less than or equal to 3. That's set builder notation. And in interval notation, we would go from -2 to 3, like that. Any questions on that? So this is a little bit, I don't know why, back in the day, when I was taking math, we did so much graphing, but students today don't seem to have much experience with graphs. And I don't know if that's your experience, but I find that a lot of students, they find graphs confusing. So you just have to remember that your x is in a horizontal direction, so you're using a vertical line to kind of mark where that is. So even though the line that you're marking, so I'm marking -3, when I go in this region over here, my vertical line, even though I'm looking at x, that's horizontal, I'm using vertical lines to kind of spot where the function is. And the vertical lines don't touch over here, so the function doesn't exist to the left here, so the domain does not include this region here. Similarly, if I draw horizontal lines, the function doesn't exist here, so that's not part of the range. It's only where the function is, and you're looking at bandwidths. So we're looking at the band from -3 to 2, and then we're looking at the band from -2 to 3. And domain is always x values, range is always y values. Any questions on that? Okay. Functions defined piecewise. Okay. Basically, that's just what it sounds like. You take some functions and you piece them together to make a new function. The important thing is that the functions, the domains have to be non-overlapping, because if the domains of the functions overlap, then you're not going to have a function anymore, because you'll have two y values for one y, two y values for one x value. So let's just look at an example. Here we have f of x equals x plus 2 squared when x is less than 0, and negative 3/2 x plus 3 when x is greater than or equal to 0. So these are the y values. This is the output. There are x's in there, but you see you're doing an operation on the x. So the answer is actually going to be your y. So this column represents the function values, the output. This represents the input. X is restricted to be less than 0. So here's the domain. So for this particular function, x is less than 0, and for this function, x is greater than or equal to 0. And it's very important that these intervals do not overlap, because then you wouldn't have a function anymore. So these obviously don't overlap. These are negative values, and these are positive included with 0. So they're non-overlapping. And so this is a function. This top function is a quadratic function, and this bottom one is a linear function. And I'm just going to show you how I would draw that. So like I said, this is a parabola, and it's been shifted to the left by 2 units. And it opens up because the leading coefficient is positive. The square is what tells me it's a parabola. And when I plug in 0, I get 2 squared, that's 4. But because 0 is not included here, it's just the edge, it's on the edge of 0, we have to use an open circle to draw it. So when x is 0, y is 4. And I'm going to use an open circle because of this lack of an equality there. And then here's the vertex. And then the other, it looks something like this. Okay, that's the top function. And you'll notice I drew it when x is negative. That's because that's the domain here. X is less than 0. So it's on the left side of the y-axis. Now for when x is greater than or equal to 0, I have a line here. This value here is the y-intercept, and it's right here. I fill it in because of this equal sign here. That's why I fill it in. And then if I plug in the value of 2, let's say, you'll see that I get 0. So this is another point, and it looks something like that. Okay, so that's the graph. I've taken pieces of 2 functions and stuck them together like that. And that's a function defined piecewise. Now, I want to show you how we evaluate a function defined piecewise. So evaluating means you just find the y value that goes with a certain x value, that's paired with a certain x value. So, for example, let's find these values. So the way I say this is here I'm evaluating f at -3. That key word there, at, means I'm looking. At means it's the x value. So if I say at -3, that means x is equal to -3. And I want to find the corresponding y value that goes with -3. So I have to plug it in to my function here. But before I can plug it in, I have to decide where does -3 lie in the domain. Here, x is less than 0, and since -3 is a negative number, we're going to be looking at this region here, x is less than 0. So I'm going to plug -3 into this function. And plugging it in means I just replace the x with -3. And if you do the math on that, or the arithmetic, I should say, -3 plus 2 is -1. I square that, and I'm going to get 1. Okay, moving on. For this example here, we have x equals 0. And because 0 is equal to 0, it's in here, right? X is greater than or equal to 0. Well, 0 is 0, so it's in this region. I plug in the 0 right here, and so I get -3 halves times 0 plus 3. 0 times anything is 0, plus 3 gives me 3. And then now if I plug in 2, first 2 is greater than or equal to 0, so it's not this function that I'm looking at. I'm looking at this again. I plug in 2. Multiplying by 2, the 2's cancel. I have -3 plus 3 equals 0. So these are the input values, and these are the corresponding output values. These are the x values, and here are the y values. And each pair is a point on this graph. So -3, 1 would be right here, this point. 0, 3 is right here. 2, 0 is right there. So you can see those points. Those are points on the graph. There are obviously many, many more points, but these are just examples that we're looking at now. Oops, I'm sorry. Now you can see the answers there. Okay. So -3, 1, 0, 3, 2, 0 are all points on the graph. Any questions so far on that? So you'll run into that in your homework, functions defined piecewise, and they'll ask you to evaluate them. Another common thing that you'll run into in calculus is we work a lot with linear functions or lines. And that's because the tangent to the curve is a line. And so we need to know how to work with tangent lines. They're very common in calculus. So I'm going to switch over now to that topic. This is just kind of a collection of algebra topics that we're doing today. Okay, so what defines a line? Well, all you need to define a line is 2 points, okay? So, I mean, there are obviously many points that define a line, but as far as knowing what the equation is or knowing the characteristics of the line, you just need 2. And that's where the slope comes in. So if we want to find the slope of the line passing through the points, -1, 7, and 2, -3. There's a formula for finding the slope, and you may recall it's m equals the rise over the run, or the difference between y values over the difference between the x values of the 2 points. Okay? And when you're calculating slope, you really have to be careful that you pick which one is point 1 and which one is point 2. It's really arbitrary, but to do the problem correctly, you just have to label, let's call this one 1 and this one 2. And then you have to be consistent. So y2 comes first, and then you subtract y1 divided by x2 minus x1. If you crisscross these, you'll get a negative answer that's, I mean, the opposite sign of what you really want. So just be careful about that. So y2 is -3, and then I'm going to subtract y1, which is 7. x2 is 2, and I'm going to subtract x1, which is -1. And if I simplify that, it becomes -10. The double negative here gives me +1, so 2 plus 1 is 3. And there's my slope. Now, the point slope form of a line. So all you need is the point and a slope to know the equation of a line. And that's called point slope form. And it comes directly from this formula. The difference is you're going to use m equals y minus y1 over x minus x1. And notice I dropped the subscript here. Instead of 2, I just have plain old y. Instead of x sub 2, I have plain old x. And that's because I want these points to vary. This is the fixed point, and these are the variable points or values of x and y. So this point x, y varies along the line, and that defines the entire line. So to put this in a more palatable form, I'm going to cross multiply. If you'll remember how to do that, you take the denominator times the numerator on opposite sides. And here, that's understood to be 1. And what you get when you cross multiply is you get y minus y1 equals m times x minus x1. And this is your point slope form. Okay, you're going to use this an awful lot when you're looking for the tangent of a curve, because when you find the slope of the tangent and you have the point, you're going to need the equation for the line. So you're going to be doing this a lot in calculus. So it's good to know how to do it. There are other forms of the line. Well, let me just go ahead and plug this information in for this particular example. So for our example, we have y minus y1 is 7 equals m, we calculated to be -10 thirds, and then we're multiplying by x minus x1, which is -1. And if I want to simplify that, I have y minus 7 equals -10 thirds. And I don't think I did this my last period, but anyway, I might have made a mistake, but you're supposed to distribute that. I think I did. Yeah, I did. Second guessing myself. So this is going to be +1, and then you're going to multiply by -10 thirds, so it's going to be -10 thirds, like that. All right. So this is the point slope form, and now as you can see, if I add 7 to both sides, I'm going to get -10 thirds x minus 10 thirds plus 7. Okay, all I did here was I'm solving for y, so I add 7 to both sides. When I add 7 to -7, it becomes 0, that goes away. When I add 7 over here, I'm going to have to find a common denominator. 7 is 21 thirds, and then plus -10 thirds is going to be 11 thirds. So I'm kind of running out of room here, but I'm going to finish it off. Y equals -10 thirds x. plus 11/3. Now, this form of the line that I have here, if you can see that, this is slope-intercept form. So here we have point-slope form. And here we have slope-intercept form. The way you go from here to here is you just isolate the y. That's how you do that. And it'll tell you which form that they want it in. They'll tell you put it in slope-intercept or put it in point-slope. So you want to be familiar with those different forms. There are two other forms that are not used so much, and let me just show you what they are. Let's see. If they want it in general form, you're going to push everything over to one side of the equation. So you're going to have some constant a times x plus by minus c equals 0. And if you put it in standard form, I'm sorry, plus c. I don't know why I wrote minus. You would have something like ax plus by, but your constant would be left over on the other side. Okay? So those are the other forms. These aren't used too often. It's mostly these two that you want to familiarize yourself with. But this should all be review for you. But I know some of you may not have had math for a while. I don't know. So I just want to make sure we're all on the same page before we get into the calculus. Any questions? Are you still with me out there? Yeah, you are. Okay. Hi, everybody coming in from Zoom. You can feel free to ask a question. You just have to unmute yourself if you want to ask a question. Don't hesitate to interrupt me if there's something concerning you. Okay, and you too in the classroom. All right. Oh, by the way, when we're talking about slope, just so you conceptually have a good idea of slope, think of a house. Okay, a house has a roof, let's say. The pitch of the roof would be the slope. And if you think about it, it would be the rise of the roof, the height, divided by what we call the run. So the slope is the rise over the run. Okay. Oh, and I should mention something about horizontal lines. Let me do that real quick. A horizontal line is a function It's a constant function because the height never changes. The height is level. And remember, the function values are the y values, and because they're the same, we call it a constant function. And we think of it as f of x equals some constant, let's say 4. So in this particular example, we would draw it like that, okay? The height of this function is 4, and it's always 4. It never changes. So it's a constant function. It is a function. It does pass the vertical line test. You can see if I draw vertical lines, each one intersects only once. And the slope is 0. Okay? So that's constant functions. The format for a constant function is just f of x equal 4, or if you will, y is equal to 4. Horizontal lines, on the other hand, vertical lines, on the other hand, fix a x value. So like say x equals 3, let's say. This is not a function. It's a vertical line, but if I were to draw a vertical line over the top of it, it would intersect everywhere. So That's obviously failing the vertical line test. So this is not a function, but you can graph it. It's x equal 3. But we don't work much with non-functions, so you're not going to run into vertical lines, but occasionally you will run into a horizontal line. Okay. So sometimes you're going to be given, and I did an example already, but let me just do another one just to refresh. So you might be given x equal 3y minus 8. If you want to find the slope of this line, and the y-intercept, you want to solve for y so you can put it in slope-intercept form. Okay. So I want to get y by itself, so I'm going to go ahead and add 8 to both sides. And that gives me x plus 8 equals 3y. And then I'm going to divide both sides by 3. So that's going to give me y equals x over 3 plus 8 over 3. And then I want to put it in a different order. I'm going to swap sides. So I'm going to write y equals, I want the x kind of separated from this third here, so I'm going to write it as 1/3 times x instead of x over 3 plus 8/3. And now we can see, now it's in slope-intercept form, so now we can see the slope is 1/3, and the intercept is the point 0.8/3. Sometimes you'll hear me say that the y-intercept is 8/3, and what I really mean is it's the y value. The point is 0.8/3. That's the y-intercept. But the value, the y value is 8/3, and sometimes I just say that. So you'll see in the homework where that they'll say in the instructions, write it as an ordered pair. And so if they say that, you would write it like this. Okay, any other question or any questions that you might have about this? Anything? Okay. Let's talk about the difference quotient now. You won't do this a lot, but you will do it in the beginning. So I just want to make sure we're on the same page. And if you've taken college algebra here, or even pre-calculus here at Georgia Southern, then you would have seen this because they do push this a lot. But it's the difference quotient of a function The difference quotient for a function is f of x plus h minus f of x over h. And for example, we're going to evaluate the difference quotient for the function. And this is how it would be in your homework. The question would be evaluate the difference function I'm sorry, the difference quotient. I didn't mean that. The difference quotient for the function, that's what I meant. F of x equals 2x squared minus 5. at 1. Whenever you see at 1 or at 5 or at any number, we're talking about an x value. At means what is the x value? If it's at 1, then x is equal to 1. Okay, that's what that means. Math language. So basically what we're going to do is we're going to take our input, in this case it's x plus h, we're going to replace x with x plus h. So here we have 2x squared minus 5, now we're going to have 2x plus h squared minus 5. Okay, that's this first piece right here. Then we're going to subtract the function f of x, which is just given to us as 2x squared minus 5. So we're subtracting 2x squared minus 5. But be careful, we're subtracting the whole thing, so you need to put the parentheses around it. And then it's divided by h. So this piece right here corresponds to this, and this piece corresponds to this, and then we are dividing by h. So now that we found the difference quotient, we need to simplify it. Okay, so let's do that. First, I want to FOIL this. So just as an aside here, x plus h squared is x plus h times x plus h. And if you FOIL that, F stands for first. The first terms are x and x, so we have x squared. The outside terms, that's what O stands for, are xh, so it's going to be xh. The inside is h times x, which is another xh. And the last are h times h, which is h squared. Then when we simplify that, we're going to get x squared plus 2xh plus h squared. We're going to replace this right here. Notice that I distributed the negative here because it's negative of this whole thing. So it becomes negative 2x squared. Double negative is plus 5. Okay? And then I'm going to distribute the 2 to each term. So we get 2x squared. 2 times 2 is 4, so that becomes 4xh, 2 times h squared, minus, okay, so here I distributed the 2. Now I've got to subtract 5. And then I'm going to subtract this, which is, and I missed the 5 in here. I got to put that in there. Forgot that. Okay. Now, the thing about the difference quotient, it is always going to be the case that lots of things will cancel. And if they don't, you made a mistake. So 2x squared minus 2x squared, that cancels. The negative 5 plus the 5, that's 0. Those cancel. And now we are left with 4xh plus 2h squared divided by h. And I'm going to factor out an h on the top there, and that leaves me with 4x plus 2h. And I bring that out, and then the h is now canceled, and it all boils down to 4x plus 2h. If it doesn't simplify to something really simple like that, you made a mistake. So, and I always do this, or it's a common mistake I make, is I forget that -5. But I always get the right answer because when I'm canceling, I realize, oh, I got to cancel this 5 here, and I forgot the -5, so it kind of keeps me on track. So it'll work for you like that too. Just know that it's always going to reduce to something simple, and your h, the bottom h, is always going to go away, okay? So now I'm not done yet, because remember, the problem says, if you'll recall, evaluate the difference quotient for the function at 1. And so remember, whenever you see at, that means x equals 1. So we're going to go down here, and when you calculate it for x equal, so you get that 4x plus 2h equals 4 times 1 plus 2h. So your final answer is 4 plus 2h. Any questions on that one? That's how you do the difference quotient. Rational exponents. So rational exponents are just another way of representing radical expressions. So, for example, let's suppose you have the 5th root of x squared. Okay, 2 is the power on x, and 5 is the root. So the way we would express this in rational, with a rational exponent, is the base is x, and then that's always going to be on the bottom. And then your power is going to be in the numerator of the exponent, and your root is going to be in the denominator. So it's x to the 2/5. Let's suppose that instead of the 5th root of x squared, we have 1 over the 5th root of x squared. So whenever you want to express the reciprocal like that, you just use a negative number for the exponent. So the base is still x, that's on the bottom, and then your exponent is still going to be 2/5, but it's going to be -2/5. That negative means you take the reciprocal of your rational exponent, or the reciprocal of your radical. Let's put it that way. Okay? The 7th root of 1,000 could be expressed as 10. That's your base, because 1,000 is really just 10 cubed. And so the root is 7 and the power is 3, so it's going to be 3/7. And if you have something like a fraction like 2/7, if you want to, you could 2/7 to the -1. If you want to simplify that, the 1 is not going to change anything. 2 to the 7th to the power of 1 is still 2 to the 7th. But the negative here is going to give you the reciprocal. Yeah. Oh, thank you. Thank you for, okay, let me just repeat that. Here you have 2/7 to the -1 power. The 1 is still going to give you 2/7. However, this negative here is going to give you the reciprocal of 2/7, which is 7/2. So that's what a negative exponent does. It just gives you the reciprocal. I'm just skimming this, so it seems like I'm going really fast. When we actually get to calculus, I'm not going to skim over things like this so much. But we're just kind of covering a survey of, like a review of algebra. And another thing you want to be able to familiarize yourself with is the quadratic formula. So let me talk about that, or just remind you, you've seen it before. The quadratic formula is used to find x from an equation that's quadratic. So for example, if you have ax squared plus bx plus c equal to 0, it has to be in this format. In other words, you have to have 0 on one side of the equation and your other terms on the other side. So a is your leading coefficient, that's a constant. B is your middle term constant, and then C is your constant value for the quadratic. When it's in this format, x then can be calculated from this formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. So you will have to use that from time to time when you're trying to solve a quadratic equation. So there's the quadratic formula. There's a problem in your homework like that, so I'll let you try that one on your own. Let me see. Oh yeah, let me look at the homework now and just go over that a little bit. So I'm going to share my screen. And in case you haven't gone in there yet, let me just remind you how you do this. So you're going to go into Folio. And we're section R. In the contents section, you're going to use this link here called My Lab Math. It's going to take you right to your homework, or well, these links here. You select assignments, and then it'll give you all your assignments. So the first 4 are all review. That's what the R stands for. So these 4 are all going to be due Monday at 11:59 p.m. Now, I'm not going to quiz you. You won't see this content on any quizzes or tests directly, but indirectly, you're going to need to know this to do calculus problems. But I'm not going to have a quiz or a test on this material. This is just for your review. And there are really not too many problems. It looks like a lot, but if you go in there, you'll see this one only has 9 problems. So this first assignment covers, here's the difference quotient. There are a few where you have to evaluate. Here you're graphing. When you use these graphing utilities, you select the shape of your graph. This is a quadratic function because of the square on x. So you select the shape, and then this negative sign means the parabola is going to open down. So, and then this 4 means your vertex, your whole graph actually has been shifted up 4. So it normally would be centered at the vertex. The negative causes it to open down, and so your whole graph is going to be shifted up here. And then you've got to find the next point. So if you plug in 1, you're going to have -1 plus 4, that's going to be 3. So you're going to take another point, and then you plug in -1. There you go. There's your graph. Okay. Then you click Save, and then check. And that's how you do these graphing utilities. Here's a question using the vertical line test. Yes, that's a function. Here's a constant function. That is a function. This obviously does not pass the vertical line test because a vertical line will intersect more than once there. And here's the difference quotient again that we did today. Here's a function defined piecewise and how to evaluate. So -1, you're going to be looking here for where -1 is. And that would be right here at the top. X is less than or equal to 2. So -1 is less than or equal to 2. So I plug it in here. That's the function defined piecewise. And here's some more functions defined piecewise and another one. So that covers the first assignment. Then you're going to go into the next assignment. Let's just take a look at that real quick. And only 8 questions, so not a whole lot. And these questions have to do with evaluating a function. I didn't really do an example like this. Remember, though, that 5 is the input value. So you're going to look on the x-axis here, where my cursor is for 5. There's 5 right there. And then you're going to go straight down to the curve. And now you're going to do a horizontal line over to the y-axis. And we see that -4 is the output. The y-axis is the output, and the x-axis is the input. So we start with the input of 5, we go to the function, and then we head over to the y-axis, and the output is going to be -4. Okay, and then here's the graph. Oh, here's the one where the domain. I did an example like this, so I'll just skip over that one. Another one where you find the domain and range. Here's the domain. X cannot equal 9 because then the denominator would be 0. So you throw that out. Now be careful about the instructions. Typically they'll ask you to put it in interval notation because that's the easiest to type in. So when your answers have an interval, now because it's all real numbers except 9, you're going to have 2 intervals joined together. So you're going to go from -infinity, and here's infinity, until you reach 9. And notice I'm going to use an open bracket. Can't see very well. Am I doing it right? Yeah. Then these symbols down here, this is intersection, and this is union. So I want to include both intervals. And then I'm going to pick up where I left off with 9 and go to infinity and close my parentheses. And I'm just going to check to make sure I did that right. Looks good. Okay. And then they want me to graph it. So it's everywhere except at 9. And see this? It's hard to see that, but those are the open brackets. So this one represents all real numbers. This one is less than or equal to 0. This one's less than 0, greater than 0. This is all centered around 9, but not including 9. So it's C. Okay, so that's how we do these. If you get stuck in a problem, remember this is the question help button right here. You can click on that. They have help me solve this. You can view an example, or you can watch a video, or it'll take you into the textbook right where that topic is. And so you can go to the textbook if you want to do that. So it has several choices here for you. Now when you take a quiz, you're not going to have this help me solve this stuff, the question help. You're going to be on your own. So make sure you learn how to do the problems before you take the quiz. But you do get to take the quiz as many times as you want. But you have to start it all over. You submit it as one complete quiz. You don't do it problem by problem. So if you don't do so well, maybe go back and review the homework before you try it again. But if you have the time, you can take it as many times as you want. Okay, let's see what else. Here's another one with domain. I did one like this in class at the start. Here you have to solve that quadratic. So x should not equal 5 or -5. So that would be, see, notice how they have it in set builder notation. Sometimes they'll have it in set builder, sometimes they'll have it in interval notation. And here's another one where you find the domain and range. So just recall the domain goes from 0 to 87.9, and that's a horizontal direction that I'm looking. So the band that I'm looking at is from here to here. It's where the graph exists horizontally. So that's the whoops. Yeah, that's right. I can't really see very well sitting way back from the screen. Okay. And then the range now is the vertical. So it's going to be, it exists at starting here at 0 and all the way up to 6.5, but it's, let me see, I guess it's 5, oh, no, not 6.5, it's, looks like 6, but it's really 5.9, so it's there. And then, let's see what else we got. It says if you were marketing a new type of hearing aid, at what age group expressed as a 10-year interval would you target? Well, you want to target your advertisements when you have the most people in that bracket. So the highest point here is around 50 to 60. So that's where you want to target your advertisements. So, okay, so that pretty well covers that assignment. Let's take a peek at number 4. Again, only 8 problems, so they're not a ton of problems here. These all have to do with linear functions. See, it's asking list the slope and y-intercept. This is a constant function, so the slope is going to be 0. And then the intercept is just 1. But here, notice the instructions here. Type an ordered pair. So the y-intercept value is 1, but I need to type it as 0, 1. The point where it crosses the y-axis is 0, 1. Okay, what else? More stuff with, I'm just going to move on. I'll let you graph it. Here's a line in general form. So I did an example where you solve for y, you bring over the 9x and the negative 4, and then you get y by itself. That will help you with that problem. Okay, let's look at this one. Here we have a linear function, which is the cost function. Now, often when you're producing units, okay, let me go back to the share screen. I'm going to use the information from an earlier class. It may not be exactly like this, but we'll do this problem. I'm going to stop sharing, and I just want to show you how to do this one problem here. So let's suppose you're producing calculators, okay? And they sell for $76 each. The cost to produce them is $7 per unit. And just to get the whole production line going, the initial cost to just even set up your operation is going to be 1,000,000, let's say 725,000. Just to set up the whole production line, 1,000,000. So you pay this out to start with, and then you start producing the product, which is the calculators. And you're going to have 3 functions. First of all, you're going to have the cost function. That's a linear function. So the per unit cost is $7. So if X is equal to the number of units, then you take $7 times X to get the unit cost. But remember, you had to pay out this much to start with. So it's going to be the unit cost plus, or times X plus the 1,725,000. Okay, so here's your linear function. You don't need to write the units there, but the slope is 7 and the intercept value is 1,725,000. Now your revenue is what you're bringing in for the sale of your calculators. So the sale is, or the revenue is $76 per unit. So you're going to take 76 times your number of units, and that's your revenue. And then the profit is going to be the difference between those. So you take your revenue and subtract your cost. Now be careful when you're subtracting your cost. You want to make sure you have parentheses around that because you're subtracting the whole cost. So this negative gets distributed throughout. And so it's going to be 76x minus 7x plus 1,725,000. And finally, your profit function is still linear. It's going to be 69x plus 1,725,000. So we work with cost, revenue, and profit functions a lot in this course. That's kind of how that works. Yes?
You distributed the negative to the...
Oh, did I not change the sign?
Yeah.
Sorry. Thank you for catching that. That's a negative sign there. And so that has to be a negative too. There we go. Thank you. All right, any other questions or comments? Okay, let's go back to the homework just to make sure I covered everything. That's the same type of problem, the cost function, revenue, profit. Here's another slope intercept thing. Here it wants you to find the point slope equation. So you're going to use, oh no, I'm sorry, slope intercept. Oh, point slope first and then slope intercept. So you're going to use that point slope form, plug in your information, and then you're going to solve for y to get it in slope intercept form. So I did an example like that in class. So you'll have that in your notes to do that problem. Here they're giving 2 points. So here you have to calculate the slope first, and I did a problem like that as well. So, and here's the roof. We're going to, now when you do this, be careful. You're not going to, the rise over the run, you're not going to go 10 over 62, right? Because the run is actually from here to the middle of the roof, right? It's rising this much, and the run is from this point to the middle. You're going to take half of this. It's going to be 10 over 31, right? So all right, so that covers everything for review. And anything else that you want to ask or go over? Otherwise, we'll just end now. Thanks for coming in through Zoom. I don't really see you, but I know you're out there, right? Let me go to participants here and see if I can see you all. Good to have you, and we'll see you next time. I'm going to end now, so bye. Takes me a while to. Oh wait, somebody has a question. Hold on. Oh.
I was just wondering, so if our like group time was like say today at like it was 11.
Yeah.
Do we have to log in to Zoom on Tuesdays as well?
I don't know how many groups are in this class. Is it 3? So it's going to be sometimes it's going to be Tuesdays, sometimes it's going to be Thursday. Okay. And you don't have to come on your group day. If you want to just do Zoom all the time, that's your option.
Okay, cool.
Yeah.
I can just like on my, so I just have to like be in this class like on my group assigned time.
Yeah, go into the groups menu, the drop down, and you'll see it there.
Okay. All right.
Yeah.
Thank you so much.
All right.